The simplest electric circuit is made of a power source such as a battery, conducting wires which carries the charge around the circuit, and load such as a light bulb. The battery gives electrical energy to the charge, and the load uses this energy. The battery gives energy to the negative charges which are carried by electrons, and this allows the charges to flow in the circuit at a certain rate. The rate at which these charges flow in a circuit has a name, and it is called current. Conventional current flows from the positive terminal of the battery to the negative terminal of the battery, as indicated by the yellow arrows. So please note that this direction is opposite to the flow of charge or the flow of electrons. Electrons flow from the negative terminal to the positive terminal. However, conventional current direction is from the positive to the negative terminal of the battery. When charge flows through the circuit, it powers on the light bulb. At the end of this lesson, you will be able to define current strength, calculate the current strength in a conductor, define 1 coulomb, and indicate the direction of conventional current in circuit diagrams using arrows. When we talk about current, we talk about how much charge moves past a fixed point in a circuit in 1 second. This is the amount of charge that passes a non-moving point in 1 second. Let's say the red line represents a fixed point and we want to determine the current. Imagine then that we were able to count the charge one by one as it passes this point. 1, 2, 3, 4, and on and on. And then we also had a stopwatch so that we can just see how much charge Q in coulombs has passed this point in 1 second. And this is current. It is the rate of flow of charge. How much charge passes a fixed point in 1 second. This is why current is defined as the rate at which charges move past a fixed point in a circuit, or simply said, the rate of flow of charge. In symbols, the current I is equal to the charge Q divided by the change in time, or delta T. The triangle in front of the small letter T is the Greek letter delta, meaning change in. Hence, we said that the current I is equals to the charge Q divided by the change in T, or you can just say I equals to Q divided by delta T. I is the strength measured in amperes. Q is the amount of charge measured in coulombs, and delta T is the change in time measured in seconds. Let us have a look at this triangle, as it will help in terms of deriving the expressions for current I, the change in time delta T, and the charge Q. We have already mentioned that the expression for current is I equals to Q divided by delta T. That is I equals to Q divided by delta T. The expression for the change in time is equals to delta T equals to Q divided by I. So that is the change in time equals to the charge divided by the current. Delta T equals to Q divided by I. The expression for the charge is Q equals to I times delta T. This means that the expression for the charge equals to Q, the charge equals to the current multiplied by the change in time. Q equals to I times delta T. Calculate the total charge that passes through a light bulb in 1 second when the current is 1 amperes. So we know that the current, or we are given that the current is 1 ampere, 1A, and the change in time, or delta T, is 1 second, and we are trying to find the charge that is transferred to the light bulb, and that charge Q must be measured in coulombs. So we're going to solve this expression using one of the expression for the charge Q that we derived using that triangle. And that expression was that Q equals to I times delta T, or the charge Q equals to the current multiplied by the change in time, right? We know that the current is 1 ampere and the change in time is 1 second. So it means that we have Q equals to 1 times 1. And 1 times 1 is just 1, meaning that 1 coulomb of charge passed through this light bulb. This means that we can define 1 coulomb of charge as the charge transferred in a conductor in 1 second if the current is 1 ampere. And this is a definition that you must know. 1 coulomb is defined as the charge transferred in a conductor in 1 second if the current is 1 ampere. The current in a circuit, in an electric circuit, is measured using a device called an ammeter. An ammeter is an instrument used to measure the rate of flow of electric charge in a circuit, which is current. The symbol for an ammeter is this. You have a circle with a capital letter A in the middle. In the last video, we spoke about voltmeters that we said measure the potential difference of across a device. And now we mention ammeters which measure the current. There are specific ways that an ammeter and a voltmeter must be connected in an electric circuit, but I will discuss that in the next video that we will do. So be on the lookout. I think I will upload it tomorrow. We have come to the end of the second lesson on electric circuits. We have defined the current as the rate of flow of charge. Current is measured in amperes, and in symbol, the current is given as I equals to Q divided by T, or the current I equals to the charge divided by the change in time. We also saw that 1 coulomb is the charge transferred in a conductor in a second if the current is 1 ampere. And we said that the direction of conventional current is always from the positive terminal to the negative terminal of the battery. And we demonstrated how arrows in a circuit diagram can be used to show this direction.